Hi, my name is Jan Wilczek from WolfSound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 10th episode of the WolfTalk podcast. Wow, we made it. We defeated the middle zero in the episode number. We're officially at episode number 10. And it's an awesome opportunity to introduce to you Alexander Talashov and Jonathan Rowden from GPU Audio. They were at the Audio Developers Conference 2022, and I see that their company is really getting more and more recognition throughout the world. And it's really awesome that I got the chance to talk to them and really ask them deeply, about the GPU audio processing. So exactly that's what we'll discuss today. We'll discuss why is processing audio on the GPUs so difficult, and why some believe it's even impossible to process sound on the GPU in real time. So their company, GPU Audio, proved otherwise. And we'll talk how their solution really allows people to utilize the power of GPU to process sound in real time. And with this, you also learn a lot about what goes into GPU processing, what are the problems that are involved, and how to possibly overcome them, and where some people actually fail to overcome these problems. And also we'll mention some resources, some references where you can learn more about this kind of processing. And I'm really grateful for the educational aspect of this podcast. So there is a lot to learn and a lot to be excited about. And when we're speaking of references, all the references mentioned in this podcast episode can be found in the episode notes under dwolfsound.com/talk010. Once again, dwolfsound.com/talk010. And it's really awesome to be able to skip the double zero at the beginning. As a final note, if you want to go even deeper and learn more about audio processing, I have a resource just for you. It's my free audio plugin developer checklist. It lists every piece of knowledge that is needed to develop audio plugins. And you can find it at dwolfsound.com/checklist. As I said, it's completely free. dwolfsound.com/checklist. And now let's process some sound on the GPU. Hi, Jonathan. Hi, Sasha. Thanks for agreeing on this talk. Could you please introduce yourself to the audience?
Sasha, go ahead.
Jonathan? Oh, okay. We're a little bit shy today. So thanks, Jonathan. Thanks, Jan, for inviting us today here for this podcast. I'm co-founder of GPU Audio, one of the guys who invented the technology that unlocks your graphics cards for audio processing. Graphics cards, not just inside your laptops and desktops. Graphics cards are everywhere, and data centers that powering up web services, embedded GPUs that can be used in the automotive industry pretty much everywhere, including the synthesizers. There is just no company that started building synthesizers with GPUs yet, but I hope that we will change that soon as well. And we basically provide a platform to bring next generation products. GPUs are extremely powerful, and I'm basically running the company, running the partnerships, running everything here in GPU Audio.
Okay, great. Thanks a lot. And you, Jonathan?
Yeah, so my name's Jonathan. I'm also a co-founder of GPU Audio, and I'm acting as CBO, bringing in partnerships, running collaborations and things like that. I come to the company as a professional musician, producer, lifelong artist. Started playing the saxophone when I was 6 years old, and turned that into a career. Branched that into the virtual immersive technology industry, where I started a couple of companies before GPU Audio, focused on producing next generation focused tools and audio assets. And when I discovered what Sasha and Basil and the team were doing, I instantly fell in love with the vision, fell in love with the company, and then I came on as a co-founder a few years ago. And since then, it's been quite the ride, bringing this technology out of the shadows into the light. And we're just super grateful for the opportunity to hang out with you today. Thanks, Jan.
Yes, it's my pleasure, and I was really psyched to see your presentation at the Audio Developers Conference 2022 and see you there. I'm just curious, like, could we really go back to the roots? And Sasha, could you maybe tell us what was the founding of GPU Audio, how it was created, and how it all started?
Yeah, the story, like, there is a twofold story behind the company itself and then the technology. We, like, Basil was the number one guy, the first guy who came to me and asked why we can't use GPUs to process sound. We started 2012, but we typically say we started 2015 because in 2012 we started with the idea of bringing audio processing on GPUs as in a form of the DAW, and we failed because it was like another project, and it was really hard to bring that kind of software back in the day, and GPUs were not ready back in the day. Then we reworked on the idea, and we figured out that it will be better for everyone if we build some sort of the engine and the platform, and with the time SDK that everyone can actually benefit from. Both businesses, users, pretty much everyone, and to make it in some ways open. And this is basically what we been presented at ADC 22nd year, right? And here with today, it was a long journey, and the entire tech, the technology, it solves some fundamental computer science issues that, prevented audio industry to see GPUs finally unlocked. GPUs are potentially extremely low latent device, extremely powerful device. It's just a little bit tricky and in some ways hard to bring like a classic DSP or machine learning DSPs to real-time audio processing solutions still. And this is basically what we are doing. The entire tech is low level. It is based on ISA, instruction set architecture. It's like, assembly language level of GPUs. We implemented part of the technology in assembler for Nvidia, AMD, in some ways for Apple M Silicon GPUs as well. And the rest is just sit on the top. It's like regular C++ code we compile and run through the CUDA and some other frameworks, SDKs, and libraries.
Okay, very, very cool. So I really then want to ask, because you touched on this, could you tell a little bit why traditionally audio industry was kind of, scared of processing audio on the GPU, and we couldn't see really plugins powered by the GPUs, which are really powerful. And I also was asked from people, outside of the industry, why don't you do it on GPUs? So like, what would be your answer?
Yeah, so the number one problem is if you're a developer, not even GPU developer, like a regular C++ guy, and you want to try new stuff, what you typically do, you download some shader language or some frameworks and SDKs like CUDA, OpenCL. Some people use OpenGL, etc., and they try things out. The problem with this is that, like the SDK example, they don't provide a typical solution for low latency processing. You can, like, out of the box, you can write a very short program, and this program can be run like with a matter of tens or hundreds microseconds. So super easy thing to do. But when it comes to processing the variety of audio algorithms and processing them all together in the real project environment made of those components and products, the complexity of this problem like evolves by the order of the magnitude, and it's hard to solve that all. So you cannot easily program those things. Okay, there is no straight way you can do this specifically for the audio industry, because typically in the professional audio, you work with latencies as low as 1 millisecond. When you do your DSP, a classic DSP implementation, you have feedback in your algorithms design. If you have a feedback, it's not easy to parallelize or to make a pipeline from the algorithm and make it efficiently executed on the GPUs, as well as a ton of the other computer science and engineering issues you have to solve. So none of those things are existing in the SDKs. So that's the reason all of the guys that tried, in some ways they failed, because they never dive that way deep as we did. Mm-hmm. There were some attempts like Liquid Sonics tried things, Acoustic Audio tried things, Neil Schneider still has his own convolution reverb uploaded on the website, still available. But there are, it's clearly what they have. They have a huge additional computing latency. They add the minimum block size is additional block size is 4,000 samples or 8,000 samples just to keep up with low latency processing. Or if you run 5 or 6 instances of those convolution reverbs, then you can have a blue screen of death on Windows and a lot of the other problems. And we know why this is happening. This is not just, I need to fix this bug. It's just a bug. You cannot make those problems disappear unless you go really to the level, as I mentioned, to the assembly language level and solve some computer science issues.
Awesome. Yeah. And please go ahead.
Well, yeah, I was going to mention, kind of piggybacking off of what Sasha said, a lot of these technical problems actually translate into business or industry problems too, right? That the industry has. So it's not just a matter of, okay, it was too hard, or maybe, the low level solutions weren't there. Without a standardized sort of baseline level of let's call it a baseline playing field, for developers, it's very hard for companies to actually form a business case about why they should use this hardware. When maybe it's only going to work on one computer and it's not going to work on somebody else's computer with a different GPU model with different drivers, right? So a big aspect of what GPU audio is achieving here and accomplishing is, we've been creating it not just as a solution for a particular product, but as a standard that everybody can use. So when it comes to that, then it's going to unlock new business cases. And I can also say that with the advent of spatial audio technology, virtual reality, machine learning, AI, the need for more accelerated compute is extremely, just to use Sasha's words from earlier, orders of magnitude higher, right? We need more compute and we need it right now. So I think the timing of this solution also really lines up with sort of answering your question as to why GPUs haven't been used in the past. Because I think the perception was in the past that, we can get around it. We can use CPU, we can use dedicated Shark chips and those types of things. But, those old solutions are quickly going off to the wayside, and we need more integrated solutions, which is what we're really working on here.
Okay, cool. And was this the appeal, so the potential that you saw in GPUs for the application that you mentioned that drove you, Jonathan, to GPU audio and made you want to collaborate with them? Was it something else as well?
Well, first of all, everyone's just so good looking and awesome and have great personalities. So of course I got to work with them, but no, I'm just kidding. Yeah, it's an interesting story on my part. I mean, I'm familiar with a lot of different really great audio companies working, bringing people together. One of my specialties in life was always finding great companies and having them come together to form interesting new products and partnerships. And one of the companies I was associated with was a very great audiophile headphone company. The CEO famously told me on a phone call when I called him one day, I had this bright idea to use GPUs for audio processing, and I called him up, knew that he had been working in the GPU industry for something like 15 or 20 years before he started the headphone company. And he told me, this is not possible. You can't do this in a way that's going to be achievable. So I always had it in the back of my mind that, for the types of tools that I personally wanted to build, GPU compute would be the solution. So maybe it was the algorithm, maybe it was Siri, or Alexa that drove me over to their profile on LinkedIn through some sort of algorithm or something. But, within a few months of having that conversation with my other friend, I discovered what GPU audio was doing, and they proved it to me. They showed me the proof case, and it was very irrefutable what they had been doing. And, I knew it was something special. And the more people I shared it with, it became really clear. A lot of other companies I shared it with in the industry at the time, they were all so many. It was like probably 75% of the companies I talked to at the time said, we've been trying to do something like this, or we are investigating this, or this is a solution that we would like to use if it was available. So that's really something that I was able to bring back to the guys when I came on was, this sort of vote of confidence that the market is ready for this, and not just the market in terms of end users, but, developers who actually want, they want to take advantage of this. I mean, the rest of the world is run by GPUs, basically, why shouldn't audio be part of that ecosystem? That's always been my philosophy.
Okay, then I have a question on, what's so special in GPUs that would, improve the world of audio? Why were the companies so much interested in the potential of GPUs?
Well, naturally, GPUs are made of a ton of the cores, like arithmetic logical units, simple cores that do simple multiplications, sums, and all that kind of stuff operations. Typically, RTX 4090 has 16,000 cores. Some other more advanced chips have more than 18,000 cores per one GPU. Data center grade GPUs, they also have a ton of the cores. Some of the GPUs also have so-called tensor cores, or like machine learning and PU stuff embedded, which is really great for like vectorized operations in linear algebra and tensor equations, which is essential part of the math for the machine learning and stuff. So answering the question, like machine learning applications shall be powered with GPUs. Like you can still prototype things in your Torch, TensorFlow, whatever you're doing with Python. You can even translate your Python scripts and release it with a C++ and get rid of all of the Python issues and release a product behind that, like Neural DSP does it. But the consequences, there will be lots of consequences. There will be like a CPU will be heated with 80% CPU usage for one instance of everything turned on quite easily, and you cannot use in like large projects and that kind of stuff. So machine learning, spatial audio, omni-channel processing, multi-channel thing, it's like another natural fit. Synthesizers and all the kind of complex, big products, devices that needs a lot of computing power. It's another easy shot. Everything that is connected to convolution as separation. This is also the best fit for GPU. There are ways to optimize convolutions, and CPUs can do a lot of convolutions, but our next partner products, or like the first partner products that we will release to the market, will prove that GPUs are the best device, and these devices can actually provide a lot more convenient way to do the audio editing and recording and stuff. And there is quite a lot. And it is also like it changed the user's daily workflow in a sense that GPUs were idle all of the days, all of the years. And now there's another device that you actually paid for. Mm-hmm. And most of us, like gamers or people who work with the video, and we just have this amount of power not being leveraged. And all of that thing can provide a great use for next generation workflows, So that's the reason why we need just to pay attention to what's possible and start to cooperate, like bringing some products on your own through the SDK or directly partnering with our company.
Okay, nice. So am I right in thinking that also then as a sound engineer, then you possibly wouldn't need such a strong CPU then, because you could offload some of the work to the GPU as well.
Yeah, I think, well, so I'll give my kind of version of the answer to that, and then I'm sure Sasha has a more technical one. But I just had this conversation recently with a YouTuber partner of ours who is going to be building a custom computer so that he could run things. And he was asking, he was like, okay, do I need to go and get this Ryzen multi-threaded, 24 core CPU? And once we discussed it, it was pretty clear that so in the past, when he would have built a computer, he would have put all his money on the CPU, right? And he would have had a very limited use case. It's like, okay, I got this fancy CPU, and half of my, or 90% of my audio software doesn't even take advantage of multi-threaded, processing. So, what's the point of getting that CPU? And it's like, well, why don't you just reallocate that extra $1,200 to a really high-end GPU? And now you've got a video workstation powerhouse, and you can also run all these plugins when things get rolling out. So in his case, the practical use case was reallocating, from CPU to GPU, and now having a system that could actually achieve even more within the same budget that he was going to spend anyways. You know what I'm saying? So I think that falls into the category of most users. When I go out and buy a universal audio piece of hardware, it's not going to play Cyberpunk at the same time, right? So, I think it's also just nice to.
Very good point.
I'm serious. A lot of the guys in our Discord channel are talking about this. Like, yeah, I'm so excited. I can use this for gaming too. And as the plugins keep coming out, I just know that I'm going to have more compute and. But it's also yeah. Anyway, that's my version of the answer for that.
Yeah, I would only add one or two more cents to it. Is that if we have a look at the hardware market, now it's more mobile, and we can have these statistics in Steam and these standard distribution. It almost the same for gamers, for creators, including audio creators. And people go mobile, okay? And today for $900 you can purchase a laptop with RTX 3060. Probably you can get 12 core CPU or maybe even more than that. But just paying $1,000, $2,000 and having a very powerful device unlocked within the same chassis is very nice. The same goes for M1, M2 laptops as well. So I think it's just very nice to have your entire power working for whatever you need.
Okay, cool. And would this also apply to smartphones then? Because smartphones are also GPU powered nowadays.
Yeah, not yet. Because smartphone GPUs are way different compared even with the iPad M Silicon. It's the same as for M Silicon MacBook Air M2 that I'm currently using. But when it comes to mobile, it's different because they have very few cores, just tens of cores, and despite they are running at a pretty high frequency, they have very low cache. And it's hard to implement the same workflows and all that kind of stuff. For example, it is hard to load IRs there, etc. So we didn't go to the mobile world because we first need to see that the real use cases are there. Okay, specifically on the phone devices. On the iPad, well, we didn't release this yet, but for us it's not a big deal to release for M Silicon GPUs for iOS, for Untracked or some kind of the plugins. It's not a big deal. Yeah.
Okay, really cool. So if you don't mind, I would really be curious to ask, from a technical standpoint, how did you manage to solve these issues with audio running on the GPU?
Mm-hmm. Well, there's an entire conference called GTC, GPU Developers Conference, GDC, of Nvidia, and we are a proud part of that. And at spring 2022, we revealed basically that overview on how the technology works. So you can find GPU audio, Nvidia GTC 22, and find the video. It's half an hour presentation, very deep, straight to the detail into some implementations. And at the ADC, we even revealed our algorithm designs, specific designs, how we solve some issues with algorithms such as infinite impulse response filter in order to be fit to the GPU architecture and executed efficiently. Because this is not just the question who is faster, CPU or GPU. You can run the same algorithm with the same execution latency on CPU and GPU, but for the same amount of time. This is all about how it can be scaled and for which purpose. Okay, so this is what we typically pitch to the audience. Like, guys, GPUs are not just, they're more powerful in a sense. You can run a lot of things, or you can use things at scale. So if you are building the next generation type of the product and you need to process like hundreds of channels of convolution, you do like spatial audio, multi-channel convolution reverb for whatever the reason, this is the best device you need to use. So we solve the challenges, shortly speaking, we solve the challenges in two ways. The one way is we wrote sort of virtual machine, you can call it, but we call it Scheduler, a specific technology that basically gathers all of the data from the CPU, from the RAM, treats GPU with data, and run whatever amount of the DSP components you want to run as parts of your product. So, for example, you can run hundreds of different types of products together, built of different types of components, settled with different types of parameters. Let me name a few. Like, you can run phasers with distortions, with convolution reverbs, made of a ton of the, like, in the entire variety of those components. You can run them together within 1 millisecond latency. So basically what Scheduler does, it just manages how many resources needs to be allocated and used for each type of the component, because DSP components can be lightweight, such as delay line, such as IR filter. They are pretty light, and some of them can be pretty heavy when it comes to computing, for example, convolution reverb, right? So Scheduler makes sure that all of those components treated with the parameters on time, do all of the computing on time, and return data back on time. So this is one component. The second component of the solution or technology is the design itself, the representation of the entire variety of DSP algorithms that can be effectively implemented and executed on the GPU. So if you have an IR filter which has a feedback, which can be parallelized, you have to find the new, better design that provides you the same output to input ratio and the same transfer function, speaking DSP-wise, that can be actually suited on the GPU well. And it goes for any other types of typical DSP algorithm. And we've found all of those designs. By the way, there is a lot of research is done for two-dimensional, three-dimensional spaces. There are researches done for one-dimensional space. You just need to Google it. And we got the entire set of designs, and we ported this, and we added a third leg, which is the unified platform thing that allows you to produce components and products on the top of that thing and makes things running together, that kind of. So it's a really complex thing, but this is what we are doing. And for the third parties and companies, this will look way nicer than I explained.
Okay, so let me maybe summarize if I understand correctly. So one thing is the scheduler that kind of gets the workloads from the CPU and then offloads it to the GPU. That's one part. The second part is the as I understand it, kind of ready-made designs for, to ease the work of developers so that they don't need to think, okay, how now I approach this to process this on the GPU, but, you have these ready-made blocks and you can use them right away. And the third thing is, as I understood it, is kind of like a platform abstraction so that you can run your solution on a variety of GPUs. Is that right?
Yeah, and variety of GPUs and a variety of bridges or integration part, whatever it is, like VST3, audio unit interfaces. Or if you want to embed it in Unreal Engine, you provide your way to basically integrate GPU audio as DLL library and run all of the threads, all of the streams on the GPU with all of the algorithms, whatever you want to run on the GPU. Yeah.
Okay. So now let's imagine that I'm a traditional CPU-focused programmer of audio plugins, right? And now you guys come to me and say that you have this incredible solution that I can, parallelize work, I can have 1 millisecond delay, etc., and it scales incredibly well, to say the least. And now, what do I have to do? What do I have to learn? How do I need to shift my thinking and my programming to be able to use your solution, your SDK?
Okay, so that's quite easy thing. We wanted, from the very beginning, we wanted to hide things from you, very complex things from you. We don't want you to go and dive deep into the GPU programming because this is another world. It is way more complex because parallel programming is like another discipline that being taught in the university. It's a hard thing. There's a lot of patterns, coding patterns, designs you need to learn. There's a lot of issues that can arise when you need to debug multi-thread application, that kind of stuff. We want to take these things from you. So what we offer you, first of all, a library which has one component like host side or CPU side, which basically allows you to just run some external process or a thread. And we offer you the very simple API that allows you just to load your GPU models or our GPU models that you then use and combine in some sort of the product you want to build. And just to basically manage the device and the instance of this GPU audio application. And there is another thing that allows you to basically code the device side part of your solution, like the exact processor speaking VST3 API wise or like audio unit wise. And basically you can write your code from scratch if you want. You can go down to this GPU programming world and you can parallelize threads and all that kind of things. But for you, we also offer the DSP primitives library. So if you want to call the FFT, here is the FFT, just pass the array there, okay? So you don't need to know what's there because as long as the FFT IE 764 standard compliant, you don't need to pay attention to what's inside, okay? It's just the FFT, right? And typical parameters for each calls like FFT like width and the other stuff like the domain that you might use in your filter on the top and or somewhere, etc. So this is more or less straightforward. You don't need to code GPU parts, but you can still do if you want to go down. We also offer some API if you need to do some non-typical things, like for the world of GPU, non-typical things like transfer some data real time, but we call it fed data. Imagine like Spectrum, sending Spectrum from GPU, it is a hard challenge actually, because you need to organize the low latent data transfers, but not for the audio, which is tiny things, but for the Spectrum, which can be like pretty decent amount of data. And you need to figure out how to do it, I don't know, like 60 frames per second. That's the reason I say this is challenge thing, right? Or if you want to load some things and precache on the GPU, like filter banks, like IRs, or you want to do some tricky things like read your collection of IRs to apply in your product, that kind of stuff. We also offer some APIs for that thing. one more thing. If you want to build machine learning thing, it will be way more different. I can't tell you how we can do this by now, but what I can tell is that we're working on the inference engine, and it will be straightforward for Python developers, just to write the Python script, then to export the library to the C++ release state and to basically translate one code to another and just use it for low latency processing. This is type of the development pain we want to also take from all of the machine learning developers. We believe this inference engine with the time, it can boost the entire industry. But this is like another story. By the way, this is the very first time I'm basically mentioning this at the podcast. Yeah,
that's amazing. Jonathan, you wanted to add something to this?
No, that was great.
So that's really amazing and much needed, I would say. And the way I understand it, it's tries to do the same thing as was shown by the Cosmo company, but what they are doing, they're taking the model and actually they're running the Python on the back end, and as I imagine, there's a much larger latency going on there. Whereas in you really kind of semi or mostly automatically will translate that to the C++ code. And that will get you all the benefits of C++ compilation and processing, but also understand that you don't have it right now because it needs to be one step at a time. So it's good that you're going in this direction as well. But what you said already is amazing. I wanted to ask.
By the way, sorry for interrupting. Because you mentioned Cosmo, we are building the partnership with Cosmo.
Yep.
So hello, Andrew 5. Yeah, we are going to make this, and we're going to make this. We basically want to test our inference engine with their system. We want to reuse it if we can have an agreement between the companies, because we believe this is like the next level thing. Like you can do,
definitely.
Imagine now you have like native instruments contact, like sample player with the libraries, all that kind of stuff. What if you'll bring something but machine learning based? It will be like another world we'll be living in.
I was just discussing this with Nvidia the other day too, and it's an exciting path. I think a lot of developers are going to wake up to AI, based compute and stuff like that. I mean, we all know, we've all been following all the Chat GPT stuff and all the generative sound issues and stuff like that.
Yeah.
I think people are just starting to wake up though, now that solutions are being built that'll make it easier and more approachable, faster, right? Like faster on the execution side. So hopefully if we can fill that notch, on the belt of what the industry is trying to achieve, then it'll help push things forward much faster for everybody.
Yep.
I couldn't agree more. So now you convinced me, you got me excited for the GPU audio. I want to build a plugin that uses the power of the GPU. I want to use GPU audio solution. What do I need to do to get my hands on the SDK?
Okay. Yeah, so this question was asked like many times, and we promised to deliver SDK many times. The reason we didn't deliver this because we know how it is shitty implemented to this date, in a sense. Like we want to guarantee you guys like very standard behavior, because even for CUDA SDK or things running on the AMD, there is like a very popular joke in the GPU world. When you work with SDKs, you see like one behavior, real behavior, another behavior mentioned in the document, like in docs, in the guidelines, and like the expected behavior, and all those things are different, and this is what we are dealing with. We dealing with this stuff, and we basically want to build something that you as a developer can be treated well, and you code things and you know how it works, and you don't want to go anywhere down to fix issues and that kind of stuff. So that's the reason we didn't. One of the reasons we didn't publish SDK. Another reason is that we are not Steinberg in a sense. We don't want to upload the SDK and generate a Doxygen thing and just say like, yeah, here it is, you can use it. Like no one clearly can use Steinberg VST3 API like straight away. That's straightforward. That's the reason Juicy exists, right? And we want to basically create a portal for developers, and we believe the best case is to make something very similar to the Unreal Engine. I just personally am a huge fan of it. The way they treat their developers communities, the way I want to treat our developers and partners. So that's the reason I don't want to produce, a shitty product. I want to make not like perfect, but at least works normally, like works standard in the standard way. So this is one thing. Second thing is we typically offer, even like to indie developers, we offer to work directly to partner directly because there are many ideas, okay, that we can all think about and we can implement. And sometimes it's hard to bring the idea to the real world because of a lot of engineering issues, as well as like sometimes bringing the ideas to the product takes like an entire company to build it, okay? And we typically offer look, we have like 7 partnerships signed already. And there are companies that you know pretty well, and there are more companies coming to us and asking to do some work with them together. What we usually offer, we say, okay, guys, if you need to speed up your existing product, please let us know where we can actually integrate. It's our DLL library, and we will just implement the processor on the top of our GPU audio engine library, and this will work for you. So this is one type of the collaboration. There are companies that are willing to build truly next generation products. So for example, just today we had the entire pre-finalized agreement conversation about what we're building together. This is another thing that will use hundreds and hundreds of convolutions running at real time thing. And I cannot say you what we are going to do, but there is no other thing or similar thing that even exists before. And we typically say that, okay, guys, if you want to bring the next gen product, we can also split the roles. You can bring the GUI. We can run your GUI in our Chromium engine. We typically embed Chromium engine in the plugins, so you can run any web GUI or a web-based solution inside the plugin. And we can run the processing thing, and we can write the processing thing for you, and you can keep the IP. It will be IP of yours. And we can then get some license fees from you, or just split or share the revenue. So this is the best way we want to work with people at this early stage, but at some point in the future, the number one way to cooperate will be through the SDK, but we are not just there yet.
Okay, yeah, I perfectly understand, and there are really few things that I hate more than some features of an SDK going deprecated.
Yeah.
So I understand that you're aiming for a good, stable, well-documented, easy to use API.
Yeah. Exactly.
But so far you see that when companies use your solution, they really need this personal contact with you to settle all the details, and I completely understand it. But from this experience, I guess a stable API will rise, and you'll see what's actually needed for the SDK, and you'll be able to provide it.
Yeah, exactly. We just made the first trials with these conferences like ADC. We organized seminars, webinars, workshops, and we saw people's reaction. It's not. I didn't realize that many talented developers that are not that way deep into either DSP or either in like C++ programming world. So I realized like, oh my God, I need to treat all of them, like the variety of developers, including like PhD students, researchers, all these guys really well. So how can I actually do this? Well, I need to unify the API. I need to keep it as short as possible. I need to keep it simple. If they want to bring something new, I need to provide like guidelines to do so. So that's why, we didn't release the SDK despite we promised so, because we saw people were a little bit confused even with this portion we gave them during the workshop. So that's actually the number one reason.
Yeah, exactly. Otherwise, your customer support will be, overflown with requests or questions, done this and that.
Yeah.
And it's not just the SDK, right? But for Juice, you have the tutorials, for example.
Yeah.
And I imagine for GPU Audio SDK, you would also then need simple tutorials. And as you said, there are people coming from different backgrounds which have different requirements, etc. So yeah, that's really a complex thing. So yeah, good luck on this. And
thanks.
Yeah,
I also on the
I'm pretty sure at some point you'll see a head of education at GPU Audio, for that reason. Once we get through another round. Yeah. No, I understand. I wanted to ask you, because you said that the latency in the GPUs, like in the communication with the GPU, was an issue. And I also, from what I understand from your presentation at ADC, is also that communicating with the GPU is like real challenge. So I wanted to ask, like, how as a developer can I be sure that when I'm using your solution for the GPUs, my audio won't glitch? Is it a guarantee that you can somehow provide?
Yeah, well, basically we provide both synchronous and asynchronous ways to communicate with GPU. So you define the way you want to work with GPU and the way you want to work with the output. Okay. We also hide things from you, like we don't allow our third-party developers to manage streams because it will be a total mess. We, as a part of the scheduler, the host-side scheduler, or the scheduler that works with the CPU world, we implemented a copy manager component that basically knows what's going on both GPU, CPU world, and it realizes how many of the client requests I've done to the GPUs and how many data transfers and like launch calls being executed in this particular buffer or time frame or sequence of calls for the particular client. And this copy manager basically manages all of the priorities. So it's done in very nice way. It works very smoothly and it's done implicitly. And that's the reason we are not typically allowing to touch anything like streams. We just provide you a way to communicate, and we guarantee the latency will be as minimal as possible, and we will ship you things as fast as possible. So by the way, you can run like hundreds of requests, like typical requests from other CPU threads within like hundreds of microseconds. It is not like darn fast, but for any type of your solution, this is enough. Like you can do whatever you want. You can implement entire bundle of effects that work together on GPU side, and you do the whole, I don't know, like recording and processing on the fly on the GPU with your bundle of instruments and inserts. You can do like synthesizer thing. You can embed like a MIDI interface. You can treat just with the MIDI nodes, with all of the MIDI parameters to the GPU, and just do the processing part inside of it. And you can do a lot of things there. So that's why we want to provide the very tiny form of communicating with the GPU. So we are both sure that you don't shoot your leg and our legs too.
Okay, so it's not just, I want to do this thing. Okay, so let's put it on the GPU to get the result. Okay, and then I want to do the next thing, and then again communicate with the GPU, but rather define the whole system and as much as you can, and then do the whole thing on the GPU to minimize the communication. Okay.
Yeah.
Awesome.
What's more important, you can define multiple independent systems or dependent systems, and the scheduler will run it all. And it will know that you're basically running all of those libraries you built on the top of the GPU audio engine.
Okay, cool. So I want to now go back a little bit to what you said at the beginning, that programmers really struggled with all this GPU programming stuff, especially when it comes to audio. You said that it's parallel programming is something you learn in the university. It's quite difficult. So I wanted to ask for people listening, which resources have you used or your developers used, and you would recommend for others who are interested in this kind of low-level programming? So not only in your solution, but also in this low-level stuff, and it involves real-time programming, parallel programming, GPU programming. Is it something that comes to your mind that you could recommend?
Yeah. So. First of all, we have most of our engineers alumni of Technical University Graz in Austria. So I basically recommend the Cathedra of Markus Steinberger. He is teaching professor. You can go to Markus and learn all of those things. By the way, I can speak that easily that Markus done researches on scheduling things, but not the exact scheduler that we built. Basically, his first big research was dedicated to rendering engine, like how to basically render things for the 3D worlds faster. And he basically scheduled all of the commands, operations on the GPU, and he compared with other render engines, and he basically accelerated things. And his students did the same researches. That Technical University Graz, you can just find him there. You can find the publications and read through them, and you can find some primitive things that we are using inside the scheduler. But our scheduler is like extremely complex thing, and it has very deep knowledge used in order to orchestrate all of that stuff. So for example, GPUs, like one multiprocessor streaming processor, it uses like minimum portion of 32 arithmetical logical units of cores to run, I don't know, like whatever the DSP component you want to run. What if you need to go down to 4 threads at the same time? There is no direct way you can do this with the CUDA SDK, OpenCL. They simply don't offer this, but you can do this on the low level. I can recommend like ACM conference papers, the Eurographics papers, research papers dedicated to the high performance computing on the GPUs. There's a lot of things still happening there. And basically we have our PhD people who won the conferences, like best paper awards. These guys are engineers. They're extremely smart. Like I'm the stupid, a dumb person comparing with them. They're extremely smart. Yeah, and the whole technology, it's extremely complex. Like you cannot understand it easily because there are lots of solutions to specific computer science issues as well as engineering problems, like problems that occur you never expect, but you have to solve it, and you have to find some practical nice way to do it, like this copy manager. Because drivers, for example, they are for Windows especially, they are written in some way you don't know how, but you have to find the best way to execute as many streams as you need with as many data batched together within tiny latency windows. This is crazy thing, and it was absolutely custom design. Like, it was hard to bring. The same goes for mathematical designs of the DSP components. So like this IR filter and its design, it's not a secret anymore. It's just like state space filters design we use there. It's like, it's not exactly the IR filter, but we just used the design to provide the same functionality, the same transfer function, to provide the same output to input ratio and that kind of stuff. And just, to emulate things rather than implement them directly. The reason why we did it so, despite that the direct form, the classic form of the IR filter is more performant on the CPU, like a little bit more, is that this thing can actually be scaled and running at scale on the GPU. And all of those papers in Eurographics and the other conferences, especially ACM, IE, they all been a great source of the designs we reused in our platform. Yeah.
Awesome. Thanks a lot. And I'll try to link to these resources on also the conferences that you mentioned and your talks on the conferences in the episode notes. And I really don't want to imagine how much work needed to go into this. So
please don't. Please don't.
So that's really, really amazing. And I now understand more why other people failed before you. So
they just failed in some way. I would say they didn't dig in that way deep, because they realized they were smart people, I believe. They realized there's just a ton of things they cannot actually control, because they don't know they can have just implicit control on things like we do in the Windows. Please don't ask me what we are doing in Windows to make this shit work. Like, it's crazy. It's like totally crazy, but we still do it because there is no other way to bring the tech, and we didn't know that it's impossible. So that's the reason why we did it.
Yeah, that's. I think it's a good argument for it. So I have a question. Then, if I was a customer and I wanted to contact you, do you have like, if I may ask, of course, do you have like a specific pricing strategy, or is it always custom depending on the client?
Jonathan?
Yeah, I mean, it really depends on the client, So we have a number of ways of working. So we have some companies that are rather large that they don't know that they want to move to productization right away. And what they want to do is they want to test out some specific algorithms or maybe some machine learning models, figure out what they want to do with it first, sit on it for a few months, and then come back to us if they want to use it. In that kind of a sense, we would probably just be working with an NRE, non-recurring engineering fee, basically scoping out the work through a budget and then, achieving whatever results they wanted. Most times those kind of things will turn into a revenue share agreement. If a company came to us and they said, here's the product, here's what we're going to sell it for, or even just like a general price range, here's the amount of implementation that it's going to take. It's just a percentage, like, and not a huge percentage or anything like that. It's within a reasonable range of like industry standards. On the licensing side, when the SDK finally does come out, in earnest, where people can work a little bit more independently, that will have a different scheme, probably really similar to the way Unity or Unreal works, where companies up to a certain amount of revenue per year won't have to pay. Companies over a certain amount of revenue will be, auditing. That's like such a naughty word, auditing, but, we'll be requesting a revenue share, or a royalty based on, what the revenue generated is exactly. But yeah, if they want to talk in the meantime, I mean, they can always reach out too. We're very open-minded about who we talk to, and I take every single call. And then a very small percentage of those, make it into the pipeline for 2023, where we bring things forward. So yeah.
we believe this is very fair approach. Like, we don't charge a ton of the money.
Yeah.
There are huge companies like tens and hundreds, I would say, millions of dollars revenue generating companies that we are working with. There are even startups or like young companies, but very promising in the way they grow, in the way they release, create and release their products, like very innovative one. We also work with them. There are like classic companies, like, very niche companies that has really good brand, powerful brands, and they just need like, a few pieces to be happy and to make their audience happy. We work with them too. And when I say all of these examples, this is exact companies that sign paperwork with us. Okay, so this is real thing. For some of the companies that still on the stage, like discovering things, as Jonathan says, we have this NRE approach, but mostly we are open in the way, let us do things for you. This will be your IP. We will monetize it. It will be like either a license fee, either revenue share, and we typically not taking a huge piece, nothing like 80% of revenue share, nothing like this, but very fair thing. So it makes like a lot of sense for both of us. If you are planning to release something innovative, something really cool that was not represented on the market yet, and you believe in this product concept, you definitely can work with us, and we can bring something for you and for the audience.
Cool. And yeah.
No, that's it.
You wanted to add something, Jonathan?
No.
Okay, so I wanted to ask, can you name specific products that already use your technology and are on the market?
Mm-hmm. Well, we have only our plugins publicly available today. So this is FIR, convolution reverb. This is modulation bundle, chorus, phaser, flanger. There is the entire roadmap we made publicly available, so you can just type gpu.audio/products and check what's going on there. There will be more cool stuff we will be releasing under our brand umbrella. There is one partnership that agreed to basically tell about them freely, which is Mach 1 collaboration, and I'll let Jonathan to tell a little bit more about that. The rest, at this stage, we cannot talk about, but what I could say is that out of those 7 partnerships signed, plus like 2 or 3 more coming, something like that, about a half or even more than a half, they are connected with a spatial audio or immersive experience thing. And it's a very natural thing. You need to run like hundreds and hundreds of channels, and or you need to run like thousands of convolutions real time. This is something CPUs can do. You can do a lot of products and a lot of new ways to how the audio can be actually processed, edited, and so on. So these are like half of the companies we have working together on these products. Cosmo thing, for example, we can freely talk about it. This is one of the 2 of the product thing we are discovering with the partners in the machine learning field, in the AI field. There's another huge company that we are working with very closely. I cannot speak about it yet, but yeah, things are moving forward. This was just half of the previous year we went public, and this is like the very first year of partner releases. You will see them very soon. I think like by summer you will see the first partner product working.
Right. And
already.
Perfect.
For a number of these partners, we are preparing marketing activities, which is something we really like to do with everybody, is share our audience with them. So you're going to see press releases starting maybe even the end of January, moving through at least March. I think we'll have 3 or 4 press releases that are coming out. So that'll be exciting to share that stuff with the world.
Jonathan, can you share a little bit more about Mach 1 collaboration, what we're actually bringing?
Yeah, sure.
With this partnership. Yeah.
So Mach 1 Technologies is a really interesting company. They're a leader in how what's the best like marketing language for it? Like flexible use SDK, you know what I mean, for spatial audio implementation. So they have plugins that you can drop into your your session, and they use a vector-based 3D audio panning method that's a little bit different than traditional ambisonics. It's different than Dolby Atmos. It's just kind of its own thing. And they have a proprietary format called the Mach 1 format, right, which is sort of like a lossless master format that everything could be sort of dumbed down into and packaged so that it can be easily deployed across multiple different platforms, right? So the idea here is that, within the spatial audio community, there's been a lot of issues for a very long time with formats needing to be changed and muxed separately, depending on what type of project you're going to put out into the world. So Mach 1 has alleviated this by creating this unique proprietary format that can be played back, with their components in any type of app. So like the same file format could be played back in a DAW versus it could be played back on the web, or it could be played back on a mobile app, etc., in a VR film, Oculus, all that kind of stuff. So what they want to do is they want to try to expand further the way that people can actually use spatial mixing tools by creating a standalone, spatial audio mixing application that will link into different DAWs, essentially. So they're creating a situation where you'll be able to process, loads more channels than you could traditionally use using like, one of the tools that I've liked to use that I'm no critic of it. I love it. Dear Reality, Dear VR Pro. Great tools. You load them on the plugins, and once you get 12 or 15 different instances, your CPU is really tapping out, right? So, and that's because it's processing, it's encoding into ambisonics and then decoding to whatever your speaker format is on the way out. But we realize that if we can offload a lot of that to the GPU, you can process 10, 20 times the amount of tracks without running into those issues, right? So the cool thing about it is it's going to be an expandable platform. So again, it's a standalone application. It'll be expandable in the sense that we can bring other features to it as time goes on. So Mach 1's really special to us in the sense that it's a long-term platform collaboration and not necessarily just like a single tool that we'll be releasing. And I think it's a great match. That's all I can share about it for now, because I know they're going to have their own press release with more details. So, yeah.
Okay, awesome. Thank you so much, and it sounds really, really exciting. Thank you also a lot for this conversation. At the end, I have one last question to you. If someone of the people listening wanted to contact you, where do you recommend they go?
First thing they can do is, they can go to the Discord. So first you need to go to gpu.audio, make an account. You just log in with your Google. We really don't email people at all. I think I emailed twice this year. One of those was just to tell people about ADC. So if you're watching this, you probably got that email, if you're on the SDK list. So I would just say go to gpu.audio. We have a number of ways to interact with us. The contact form will probably take you to our hello email address. So it's just hello@braingens.com. You can also just email me directly, jonathan@braingens.com. It's just JONATHAN. That's probably the best way. If you're a developer, reach out to me directly and I will put you into the pipeline for conversations. Once you make an account on the website, make sure to go visit our Discord page. The Discord is mostly users like producers and stuff, but we do have a couple of GPU channels in there for more technical discussions. Sasha is pretty active in those technical channels. I'm more active in the other channels with general users. And we actually have like a really cool event going on right now too. Do you think is it cool for me to share about it?
Yeah, go on, please.
Cool. So one of the things that we like to do is, we're trying to expand, the vocabulary of the average musician to like understand like what they can do with audio in general, right? It's like, GPU audio is a low-level technology. So we view ourselves as a low-level company, right? Like we're a company at the basis of everything that's trying to bring people together. So we've realized that we actually really like to do community events. So we're doing this thing called the IR competition right now. It's sponsored by a bunch of really cool people, Dr. Mix, other guys like that. And what we're doing is we're challenging people to create their own impulse responses. And the reason is not just for fun, but it's also because we want to test out user-made impulse responses within our, methods, right? So we thought, okay, how can we basically create a situation where we could potentially get hundreds, maybe thousands of impulse responses to try out and really see, how our algorithms are standing up to it and stuff like that. So what we did is we've created this contest called the IR Challenge, and we're challenging people to create their own creative impulse responses using whatever method they choose to create virtual space, because with the number of partner products coming out and just a number of different factors, we feel like this is going to be a really relevant conversation to have, both in the developer community as well as the producer community, and it's just fun. So this is the kind of the vibe of GPU Audio. We're deep tech, but we're deep fun, I guess you'd say. Work hard, play hard. I think we're one of the companies.
Yeah, so I can go and record my own impulse responses and then send them out to you. And what are the criteria for the winner?
So the criteria is it sounds the coolest and is voted on. So there's going to be a voting process, yeah. And there's lots of prizes. There's like over $6,000 in prizes, including GPUs, laptop, stuff like that. So. Laptop. Yeah. And one of the coolest things about this is that we're going to make all of the impulse responses, at least the winners, if not like everybody, we're going to put them on a repository for everybody to dive into, right? Because we know that impulse responses are one of those things that, we'll spend hours at 2 a.m., 3 a.m. digging for the right sound of the right room, right? So, we thought, hey, what better opportunity to try to activate a community of thousands of people to submit them, and then we can all take part and have fun with them. And, everybody can keep their own stuff. We're not trying to sell anything. It's nothing like that. We'll just make them available to the community. So, yeah. That's it.
Yep.
GPU.audio/IR competition. I believe that's the...
IR competition. Yeah.
There you go.
Okay. I'll also link to it in the episode notes, and I guess there'll be an additional prize if you manage to break GPU audio software.
We'll see. Yeah.
Yeah, cool. But it's also a great way.
Oh, I was just thinking, it's like the sign with $1 million of cash in it, where if you could break this glass, you can take the cash. Have you seen that?
Yeah. Or GPUs.
Yeah.
Nice. Yeah. There's also a beautiful way to contribute to the community, and it's, I guess, a win-win for both sides. Yeah. So, thank you very much. Thank you very much from my side. I think it was very, very educational for everyone, because GPU topics, as you well know, are not very popular or common among audio programmers and audio developers. Is there anything you would like to share at the end of this talk?
Well, follow us. Please sign up. Please follow the news and prepare for this year. If you didn't upgrade your GPU system, whatever you have, please buy just like, I don't know, even M1 MacBook Air. They're dirt cheap right now. And once you upgrade it, you will get all of the products that are coming. Working really well, perfectly, yeah. Thanks, Jan. Thanks again. Thanks for the audience, and see you next time.
Exactly. Thank you. Thanks a lot from my side.
Yeah, thanks again. And yeah, big thanks to the audience for watching.
My pleasure.
Yeah. Thanks a lot, and good luck.
Thank you.
All right, everyone. That was Alexander, Sasha Talashov, and Jonathan Rowden from GPU Audio. Thanks a lot, guys, for this awesome talk. And I would kindly like to remind you listening that their impulse response competition, the IR competition, is still open until the 23rd of February 2023. You can check it out under gpu.audio/IR competition. gpu.audio/IR competition. I have also linked to it in the episode notes, which of course you can find under thewolfsound.com/talk010. If you'd like to support this podcast, you can leave a YouTube like and subscribe. You can also let me know there in the comments. Or you can go to Apple Podcasts and leave a review there. I really, really appreciate it. As a small reminder, you can get your free audio plugin developer checklist under thewolfsound.com/checklist. Once again, thank you for listening, and I hope to see you in the next episode. Take care.